Now we're going to have a look at permutations. Before you begin, please make sure that you know what factorials are and what they do. Have a look at this question. Here are 4 different boxes, box A, B, C and D. My question is how many permutations are there of these 4 boxes? Now the first thing you need to know is what a permutation is. Very simply, a permutation is just one arrangement of these 4 boxes. So for example, B, D, A, C is one permutation. Another permutation would be C, A, D, B. Another permutation would be A, B, D, C. These are all permutations, they're just different arrangements of the same 4 boxes. And I want to know how many permutations there are in total. Instead of counting them all out, there's a much quicker way of doing it. Let's have a think. For the first box, the first space, there are 4 different options we could take. We could take box A, we could take box B, we could take box C, or we could take box D. Now for each of these 4 to fill the second box in, there are 3 more options. So for example for A, the second box could either be B, C or D. This one could be A, C or D, this one could be A, B or D, and this one could be B, C or D. You can already see there are lots of options. For the third box filling, there can be 2 on every single letter, because there are 2 options left for each one. So if you have a look, it really gets very big very fast. And I'm not going to write those down, but you can imagine what the options are. And then once you've done that, to fill the final box, each one only has 1 more option to go to. So that's still very long, but there's something very cool here. If you notice, there are 4 ways to choose the first box, there are 3 ways to choose the second box, there are 2 ways to choose the third box, and 1 way to choose the fourth box. So we're going to do 4 times 3 times 2 times 1, because each time you can have any of the 4 or any of the 3 or any of the 2 or any of the 1. So 4 times 3 times 2 times 1 is 24, and that's our answer. But another thing that you need to notice is that 4 times 3 times 2 times 1 is also 4 factorial. So now we can see factorials are showing up in these counting questions. What we've done here, and you need to know this, is called the product rule for counting. Because we are taking products, we are multiplying numbers to count how many permutations there are of this. Okay, let's do another counting question. This one's going to give us one of our formulas that you need to know. So there are 5 ice cream flavours, A, B, C, D and E, which I've drawn over here. And I want to have 3 scoops of ice cream in a cone. Now because they're in a cone, if you have a look, the order that we have them matters. So having black, black, red is not the same as having black, red, black. They are different. And also, as you can see, I can have the same flavour more than once. So I can have the black scoop twice. My question is how many different ice cream permutations could I have? How many different ice cream cones could I have? This one to solve is even easier because there are 5 different choices of ice cream for the first scoop, there are 5 different choices of ice cream for the second scoop, and there are 5 different choices of ice cream for the third scoop. So it's just 5 times 5 times 5 because that is the total number of options I could have. And this is 125. And the other thing you need to notice is that this is the same as 5 cubed. Why is this important? Well, you're going to see right now. Okay, in this red box is the formula for permutation with repetition. Now it looks scary, but we're going to get through it. So, what it means is that if you have n, which is the total number of things, in our case the 5 scoops of ice cream, and you want to pick, the P is for pick, 3 of them, R is the number of items that I want. So if I have 5 scoops of ice cream and I want to pick 3 with repetition, so I can have the same scoop twice, this will be equal to the number of choices I have raised to the power of the number of things I want. So in our question, the answer would have been, we would have done 5 pick 3, which would have been 5 cubed, which we know that was right, it was 125. And that's a quicker way of doing these permutation questions. Now we've looked at permutation with repetition, we need to have a look at when there's no repetition. My brother is a bit more picky with his ice creams. He'll only have 1 of each flavour at most. So if you have a look over here, he wouldn't have 2 scoops of the red ice cream, but he can have 1 of each one at most, which means that there's no repetition. Once you've had 1 scoop, you can never have it again. The question is, how many different ice cream cones could my brother have? How many permutations are there? Well, think back to the very first question. There are 5 ways of choosing the first scoop, but once he's had that scoop, there are only 4 left to choose from. So the second scoop, there'll be 4 options. And then for his final scoop, his third one, there will be 3 options. And that's it. So it's 5 times 4 times 3. And this is 60. You should also see that this here is very close to 5 factorial, but it's missing the times 2 and times 1 bit at the end. Now let's look at the formula for permutation without repetition. So again, n is the total number of items that we want, and we want to pick r of them, r being the number that I want. So for example, in our case it was 5 ice creams, pick 3. Without repetition, this will be equal to the number of items we have factorial divided by the number of items take away the number of items we want, all factorial. So let's work this out with the question that we just did. We had 5 flavours of ice cream and we wanted to pick 3 with no repetition. So this will be equal to 5 factorial divided by 5 minus 3 factorial. And this will be 5 factorial divided by, well, 5 minus 3 is 2 factorial. What will that look like? Let's expand this so you can understand how we get to the answer above. This will be 5 times 4 times 3 times 2 times 1. And this will all be divided by 2 times 1. Now remember, when cancelling fractions, because they're all multiplied together, this top thing has a factor of 2, and this bottom thing has a factor of 2, so we can cancel them. And because 1s don't change anything, we can get rid of them as well. And that will leave us with 5 times 4 times 3, which is what we had above, that's 60. So you can now see that without repetition, when we have n pick r, this here is our formula. Luckily for you, you won't really need to input this scary formula into your calculator, because there is a button for doing no repetition permutations. And that button is just above the times sign in both of the calculators, regardless of which one you have. So for our question, if you wanted to find out the answer without writing all those numbers down, all you needed to do was write 5 in your calculator with the 5 key. Then, to get to the PNPR thing above the times, you've got to hit Shift and then hit the times, and that will give you your P. And then you hit the 3 to say 5 pick 3, and when you hit the equal sign, it will come up with 60. That's permutations done. In the next video, we're going to look at combinations.